Welcome to the AntiPattern Podcast, your ticket to the revolution in digital thread technologies. Please welcome, live from Mannheim, Germany, your hosts, Christian Muccio and Michael Fenning.
Hello and welcome everybody again to a new year, to the AntiPattern Podcast from Mannheim downtown. Together with me again in the studio is Christian, our CTO. And a couple of things are new. First of all, we changed seats. I'm not sure if this is getting obvious. You're not watching that video in a mirrored version, right? So we did that on purpose. So we changed seats here. And today is the first episode of 2026. Christian and myself, we just came back from skiing to the Austrian Alps, to Sölden. We came back yesterday evening after a very long traffic jam, which was unusual and very painful. And we made it. And today we're back in Mannheim in the studio. And we said, okay, except for skiing the last 3 days, we also kind of were talking about what we wanted to do in the first episode. And we came up with one thing that has been, I don't want to say bothering us, but we received a couple of questions. Can you make sure that we really understand what you guys are doing? And so today we want to talk about, what is it that we want to talk about?
Basically, the topic today is about the digital thread again, but especially on the topic of the active versus the passive digital thread. And a friend of us published a paper a while ago, and this definition that he raised in this paper and the explanation is also a perfect explanation for us if we got the question, are you just yet another data analytics tool? Yeah. Because sometimes people cannot really grab what we are doing.
Right.
Especially also because we say we are not the next PLM system, which brings sometimes even more confusion to the people.
Right.
And and also the term digital thread is used very often at the moment, and
in different ways.
In different ways, yeah.
In different ways.
So
the understanding,
the problem. Yeah.
I guess the community did not really reach a conclusion on the term.
Yeah.
Not in all of the details, not of all of the cases, so to say. So today we try to minimize or maybe even get rid of the confusion about what is it that Elevating Patterns is actually doing. So yes, there are so many different data analytics tools out there for so many different purposes, right? One is, of course, Palantir, that many people know, right? But that's not what we are doing, right? And there is others, and many of them are basically focusing on get some data out of existing tools or from spreadsheets, right? Visualize them, analyze them, understand what the data means, right? And then make a decision and then throw it away, right? And the next project, right?
And there are also quite a lot of tools, even in the German-speaking region, for or with an engineering purpose.
Right.
These are the tools we are mostly confused with.
Yeah, or compared to.
Yeah, or compared to, yeah.
Which is fine, right? It's definitely fine to compare us to existing tools that serve the purpose of traceability and adding semantics to existing data sets, right? That's definitely the case. But what we want to do is we set something on top, right? We want to do something more. We want to go at least one step further, right? I would call it more than one step, to be honest. But yeah, so we want to set on top of that concept and make that, let's say, passive digital thread. We want to make it active, right? And how do we do this? We say we are not just data analytics. Of course, you need semantics. Of course, you need to understand what data means, right? Of course, you need to do that. But we want to orchestrate and not just analyze, right? So what's the difference between orchestration and analyzation, right? You take the data, you do something with it, you follow some kind of business process, and then you bring it back to the existing and connected tools. Right? Yeah. So it's not just one way, get it out, analyze, ensure traceability, and then forget about it after you made some important decision, right? It is analyze, check it, reconfigure, right? And then bring it back to the silos that have been connected to it, right? So that is the idea. And this is what we call data orchestration, right? Or in other words, and this is not new, this is actually a concept existing for a long time, is we want to be the backbone the data management backbone in the engineering or in the industrial process, right? For a best-in-breed approach, right? So don't have to use just one suite for everything, right? You can use the best-in-class tool for the problem that you have, right? And we take the role as the orchestrator, bring data from here to here and make sure that the configuration of product data is correct where it needs to be. Right?
Yeah, and I think this is the most important point, that we, on the one hand, are not just the database in the background, because we want to transport information from one to another place. You already mentioned, yes, you need to have to add semantics, or you need to understand semantics, which is also already one step further to being just the graph database, and maybe as one implementation of a knowledge graph in the background. I think the most important thing is data management itself, which some sources will do for certain purposes and certain business processes. But I think the main challenge for most of our potential customers is to bring the data management from the different silos into a common data management on top.
Right.
And this is exactly what we do, that we orchestrate the common data management, which means that we maybe add life cycles or dependencies on different life cycles, which are controlled by our platform, or the data in our platform in that moment.
Right.
And that makes this passive digital thread active for me.
Yeah, definitely. And before we come to the question of what is it that data management entails, right? So what's in it, right? And multiple different concepts, right? That you need to integrate and make sure that everything stays consistent, right? We come to that in a minute. We first wanted to talk about the integration problem, right? Because that's an obvious, right? This is, one of the elephants in the room. How do you integrate with multiple tools, and how do you make sure that everything, is consistent to each other, right? And there is at least two integration problems. The main two are the horizontal integration and the vertical integration. So horizontal integration means we do understand what data means in different tools, in different silos, in different domains, right? Along the whole product or system lifecycle, right? And this is, our solution to that is we have our own meta model. On top, we have domain-specific data models, and we can, make sure that things are understood and the connections between them are also understood. So this is the horizontal integration. Bring the data from multiple tools together and make sure that in one joint big data model, as a basis of the knowledge graph, right, we do understand what things mean and how they are connected, right? This is the horizontal integration. And this is something we can solve basically on our own. We are not dependent on anybody else, right? We just have to make a really, really good job bringing all of that together, right? But this is something we are not dependent on anybody else. We just need to understand, right? We need to understand the use case, the business process. We need to understand the data, right? And then everything's fine. With the vertical integration problem, it's a little different, right?
Yeah.
Vertical integration means how do you get data from the external tool into ours and back, right? And there you see some dependencies, definitely. And
Absolutely.
Sometimes better and sometimes it's easier to integrate, right?
Yeah. Yeah, I think the main challenge for us will be what kind of tool or which generation of tool do we see on the other side?
Right.
Is it something web-enabled with great APIs? Then a connection might be absolutely achievable, easily achievable.
Right.
Instead of the other extreme, and I think we already mentioned it in another podcast episode, is you have the old school on-premise, if you're lucky, XML enabled solution.
Or CSV.
Yeah. And somewhere in between, the truth will be.
Yeah. So the best tools to integrate with are usually also cloud-native solutions. We're not really worrying about them, right?
Yeah.
Existing LLM systems, for example, usually not a big deal.
Yeah, it's the best example how these ecosystems shall work. Also for mechanical engineering or electrical engineering.
Right. And then talking about on-prem solutions, right, which is the integration problem is bigger because some of them, not calling out anybody, but some of them are not meant to be integrated, right? So they are very closed, right? And the APIs are not open, right?
But in these cases, our customers should think about if these are the right tools for them for nowadays.
Yeah, if that's really a strategy that they want to support of those tool vendors, right? So openness for us is a definitely something so important that a vendor that is not open is, for me, it's a red flag, right? Definitely. And then the other thing, of course, is the connector to those on-prem tools. So if it's open, if you get data out and in, or to say it more specifically, the data you need to get out and in, right? Mm-hmm. Sometimes, certain things are closed, but that does not really interfere with the data that you need from the tool, right? And it's also kind of okay, right? But if you get data in and out, the question then is, how do you set up the connector? And if you want to build such a on-prem connector to our cloud-native tool, right? The question is, where do you do the mapping? Do you do it on their side? Do you do it on our side, right? Our preferred approaches do it on our side because we invested heavily in mapping tables and how you do mapping, how you can easily, by dragging and dropping, create a mapping, right? We did see that in the demos that we did, right? So we would like to have, of course, the control over the mappings to the existing connectors to the external tools, right? It brings everything together, makes it easier for us. If that's not possible, right? If the mapping needs to be on the other side, right? Then we need to figure out how exactly this is going to happen, right? But also doable, of course, right? We will not be, standing in the way if that's necessary in a project.
I think in the end, the thing that we can guarantee is that you can easily map data on our side, and you can update this mapping easily. This is something we can guarantee of. But on the other side, if you have this mapping on the software to be integrated on site, we cannot guarantee how fast you get people and the service to adapt to new mapping versions and so on.
Right. And last but not least, on that topic of integration, we of course are talking about server-to-server connectors, right? Mm-hmm. We completely exclude everything to the desktop tool, right? In the moment, at least.
At the moment, yeah.
Yeah. There, of course, are some solutions, right, where you say, okay, I have a CAD tool on my desktop running here, and I want to directly connect to your tool, right? Maybe that comes up in the future. For now, we expect scenarios where we connect to another, server-based solution, whatever that means, right? Makes it easier anyway, right? And this is the way to go for the moment, definitely.
Yeah. So a CAD tool might be, or is comparable to a browser. Yeah, it's a tool that connects to our service and shows data to the user.
Right.
So, as long as it is just showing data, this might be achievable very quick from different vendors if they are interested.
Right. So this is covering the desktop tools, right? Something to be solved in the future. But I guess one question that people may have is, we say, there's this knowledge graph and you want to understand data coming from different files and then you want to do something with it, orchestrate, bring it back, right? What is the orchestration part in it? Right, so what do you do with the data? What is the data management, consisting of? What different disciplines do you need to bring together to actually manage engineering data or technical data? Right? What is it?
So basically, we could start a PLM lesson now, basic PLM lesson. But to make it short, I think one very interesting use case is the versioning. And all of the tools, these federated tools, or many of them do versioning by themselves,
right?
But maybe in a very detailed way, which is important for this certain domain. But if you want to connect the results of this one domain, you might not need each and every minor version in this digital thread.
Right.
So therefore, it might be interesting to get thread-wide independent versioning, to control what is going when, where, especially when a life cycle is reached, for example. So life cycle is the next thing. This could be existing on the federated side, but it makes definitely sense to apply these life cycles also on this upper level. And of course, there will be interdependencies. So if a life cycle on the federated sites reaches, I don't know, a release status, then something might be triggered and automatically be achieved also on our side.
Right.
But all of the other data analytics tools that we are sometimes compared with, I'm not aware that they have an own lifecycle map service on their side. But they show just what comes from the source.
Right. Right.
Then, yeah, also compared to versioning, I think we need to distinguish also the historization. And this is something where we are pretty much inspired by Git. I think we also talked about this in a prior episode. That sometimes also on this higher level, because you as domain A engineer don't have detailed access to domain B, but you are not just interested always in the latest, greatest information.
Right.
You might want to see what was happening in history.
Right.
And therefore, some commit-like engine that we have in our platform enables, all engineers on the whole life cycle, or not even engineers, and all actors on the life cycle to see what was happening in the history.
Right. To say it in maybe in different words, so the comparison between history or historization and versioning. Historization means who changed what when, right? In all of the details, right? Even if it's just one small value in one field of one entity, right? All of that is tracked, and every detail that you can imagine. This is historization, right? And then on top, we do understand versioning to be something that a user decides to be the next version, right? It's not happening automatically from the system, or maybe it's triggered from somewhere, right? But usually, the main use cases will be a user says, "Oh, this is now version C," right? And how he wants to call it also, of course, configurable, right? Can be 1, 2, 3, can be ABC, can be whatever, right? You can come up with your own scheme for this, right? And this is the difference between historization and versioning. The next thing that you have on your list is validity and effectivity. And just wanted to say one thing. This is the one thing that ERP systems do pretty well. Yeah. And this, of course, is also something we want to bring into the graph, right? Because I'm not sure if you could say PLM systems do this not so well. Maybe they also do it, right? But if you have some of the components of actual data management in ERP that actually works really good, this is effectivity, this is validity, right?
Yeah, that's true. Yeah. And being by terms starting with V, you also have variability. And this might also be a very interesting use case for many customers, because I have seen in my life as a consultant so many cases where more or less the same information, variability information, was handled in different tools. So the sales guys had their CPQ tool with their kind of variability model to get a quote, for example.
Right.
And a totally independent variability model on the engineering side, which are the guys who have to create these things that the salesmen are selling. And this constant inability to synchronize, these are just two of many possible variability models. So we are not speaking of variability because you are producing something in America and in Europe,
right?
Which is another very interesting use case. So all in all, bringing these variability models together in a higher place and syncing them with single domains is a very interesting use case, which is also totally different to anything that analytics tools might do.
Yeah.
So maybe analytics tools can tell you, oh,
there are variations.
There are variability models,
right,
and they are different. Oh, yeah,
right.
Good information. I could tell you without analytics tool.
Yeah.
Yeah, but bringing that together, knowing, and then there we are back at semantics.
Right.
You need to understand how is the variability model modeled on the one side, how is it on the other side, and mapping them is
how do you bring it together?
The use case.
Yeah. Yep. Right. And one thing on variability that comes to my mind, that we should actually add, because we are currently working on our first implementation of a variability service, right? So we want to have variability deep in the core, right? It's not just one application that you can use here, right? Variability can be used everywhere, right? A requirement can be subject to vary, right? To variability, or a bill of material, right? Or a maintenance plan or whatever, right? Everything can basically vary or subject to variability. So we want to build it as a service. And what we are very, very sure about is we need to have constraint-based solving for it, as well as Boolean solving, right?
Logic, yeah.
The logic for both needs to be there, right? Yeah. Because sometimes you just want to say, okay, this excluded, right, or included, right? And sometimes you want to say, I want 5.5 meters of a cable, right? So both of that needs to be, of course, integrated, and it needs to be a joint concept for both, right? We know that. The question is, what do we implement first? Right, it seems to be that the Boolean part is the easier part, maybe, right? But let's see that we bring all of that definitely together.
Yeah, and that will be a task for two different parts of our software.
Yeah.
So on the one hand, we have to have a variability model in our meta model. So that means the common basic logic of each and every variability, of variability. For example, the variation point.
Right.
This is something that should
really
go
common.
to the meta model.
Right.
But all the other things that Michael explained recently, they are up to the service,
right,
and might also be adaptable,
right,
and customizable later on.
Yeah, exactly. And then you have change management. I put it down because sometimes people confuse that, right, and say change management it's everything, right? We see it the other way around, actually, that change management is part of data management, right? Data management is more than just those things that we already mentioned. Change management is important because you will not just want to ensure one configuration, you also want to make sure that the process of how you come from one configuration to the next one is controlled. And this is where you need the change process, right?
Yeah.
Well, what are the artifacts that need to change when, right, to make sure, and who is it that needs to approve and sign off of something, right? So this process is, of course, also part of data management. And last but not least, and this is maybe the theme of today, or the learning for today, all of that, if we bring all of that together, data analytics, semantics are important, traceability is important. There are already tools doing this. We want to set on top data management. Data management means to us a lot of different things, and we want to make it as generic as possible, because you never know what happens, what is required in a project. So we want to make it as generic as possible, and we want to set it on top. And then we combine all of that together to create the active digital thread, right?
Yeah.
Get data in, reconfigure, bring the data where it needs to be, and trace everything.
Yeah, and I think this generic approach is very important to outline again, because this is exactly the reason why we did not come up after 6 months with a hard-coded app which we could sell instantly to thousands of customers.
Right.
This is exactly the point why it took the last year, and it will take also the next years to enable the platform to be that generic.
Right. So being generic is really, really important to us. And the other thing is standards. One standard, or there is not just one standard for it, but standards we should mention in this context is all the standards existing for configuration management, CM2, for example, right? Change management 2. If you read them, you will be reminded of a lot of things we talked about. The main thing you should remember is When we talk about config management, we do this for data structures. We don't do this for documents, or we don't have just documents in mind, right? So a lot of those configuration management standards out there, they talk about documents that need to be configured, right? Or the set of documents is to be configured, right? And this is not really the case anymore. Everything is model-based, everything is data-driven. So we talk about config management, change management and config management for data structures. Right? And that's important. And that actually basically means if you have a data analytics tool and think of it, what is it that it's doing? What are we doing in addition to it? We bring configuration management of data structures to that semantic layer, right? Combine all of it and make it the backbone for a best in preach, best in preach, not in preach,
not preaching.
best in breed approach for industrial processes.
Yeah.
Right. So with that being said, I hope we got rid a little bit of the confusion, right? So what is it that EP is doing, right? I hope that came across. With that being said, thank you very much for listening in to the first episode of 2026. Talk to you soon. Next episode will be in February. And with that being said, thank you for tuning in and goodbye.
Goodbye.
Bye-bye.